Okay, everybody, this is the last part, second part of the 10.3 lesson. So this is page 11 of 10.3. And the question says, use the graphs below to answer the following questions. And I don't want to make these graphs any smaller because I want to be able to kind of point to them. So I'll write the questions up here. You can just work below it. A is f of g of 2. So this is actually just like this question here with the table that we did yesterday. So if you weren't in yesterday's class, you haven't seen yesterday's video, go back and watch yesterday's video to see how we do example 2. Otherwise, what we're doing right now isn't going to make much sense to you. Okay, so I want f of g of 2. So that means, remember what this means. This means the x value is 2. And then, of course, that part, okay, that's what this 2 means. And then, of course, this part means what is the g value when x equals 2. And then, of course, this whole thing is saying f value when x is, I don't know, I got to figure that out. So, first, let's find g of 2. So g of 2, when x is 2, the g function is -1. So now f of -1, when x is -1, the f function's value is 4. So there we go. That's the answer we get. We get the answer 4. Right? So do you want me to run through that again, just to show you again what my steps were, starting over? So step 1, what is g of 2? I didn't mean to erase that. Step 1, what's g of 2? Okay, so g of 2, when x is 2, oops, wrong way. The g function's value is -1. That's how I got that number. Then, putting that into the x for f of x, when x is -1, what's the f function's value? And the answer is 4. So if that all made some sense to you, you should be able to do b without me. So I'll give you a minute and see if you can figure out g of f of 4. Okay? So see if you can figure that out. And I'll get to that question that just popped up on the chat after we're done this lesson. Okay, so was that enough time? Let me erase that again. Okay, so f of 4. So on this grid here, when x is 4, the f value is 2. So I'm actually looking for g of 2. And when x is 2 on the g function, we get -1. Any questions on how I got that? Okay. All right, I'm going to move over a little. And I'm going to do C over here, even though you can just work down, but I don't want to lose my diagrams. And C is determine the value of x. So basically, you're finding x if f of g of x is 3. Well, interesting. F of g of x is 3. Now remember, f of x, or f of g of x, or f of anything, is the y value. So this is asking you, when the y value on the f function is 3, what is the number? So, so let's see. I'm basically asking you, f of what makes 3? Okay, so f of what makes 3? So, f of x has a y value of 3 when x is 0. So there we go. So that means that this inside here must be 0. So that means g of x must be 0. When is g of x got a y value of 0? g of x has a y value of 0. Aha! Here and here. So x here actually has two answers. It could be -2 or 1. Both of those are true answers. And if you're doing a question like this and you want to check to see if you're right, can I erase this part now? Now that we're done these questions. You could do a check on this. Just go forward. My check should be, if I'm right, then f of g of -2 should be 3. So should f of g of my other answer 1. Let's see if that's true. Are both of those true? Let's try them. Let me erase those points so they don't bias me. Okay, so when x is -2, on the g function, what do I get? I get 0. When x is 0, I get 3. Check. On the g function, what is the y value when the x is 1? It's 0. And we already know f of 0 is 3. Check. So yeah, that's my answer. So really, this is just like the chart questions, but in graph form. And this is as close as we're going to get to graphing for our Chapter 10 assessment. Is I might throw one of these on there. Okay? And I think there's one on the homework page for you to play with. Okay, moving along to more interesting things. Given f of x equals x plus 3, and g of x is equal to x squared minus 4, determine g of f of x and identify the domain. Okay, so g of f of x means plug the f of x in to this x. So g of f of x will be square root of x plus 3 squared minus 4. Sweet. So that's going to be g of f of x is equal to, well, when you square a square root, you are just undoing an operation. So those two operations cancel one another. And g of f of x is equal to x minus 1. So x minus 1 is, of course, linear, right? That's just a line, right? This is the line, right? So I'm going to put it over here. This is the line y equals x minus 1. You'd think, let's do the second part of the problem, identify the domain. Isn't the domain of something linear just infinity? Don't you go from positive to negative infinity, right? Doesn't the line y equals x minus 1, well, you have a y-intercept of -1, and then you go up forever in the slope of 1. So wouldn't it be just y is an element of reals? Actually, no, it isn't. How come? Let's go to Desmos. Take a look. Desmos. Just going to pop over to Desmos here. Desmos. Okay, that's not for you. That's for the grade 11s. I think I saved this, didn't I? There it is, 10.3 examples. I did. I saved it. So there's the first graph, right? X plus 3. There's the second graph. So the first graph was square root of x plus 3. Second graph was x squared minus 4. And then when I plugged f of x into g of x, I got a straight line. And I'm expecting, when I graph y is equal to g of f of x, I'm expecting a straight line. Look what happens. Can you see that from where you're sitting? There is a halt. I get to here, and it won't go any further. I'm dragging it to as hard as I can, and it will not go further. Why is this happening? Any ideas? I'll give you a hint. It doesn't have anything to do with the purple graph. Whatever. It's because of the green graph. Can you see it now? Right. The problem here is the square root. And this is actually a rule that we should get into our notes. The domain here is, identify the domain. The domain here actually is that x has to be greater than or equal to -3. Why? And this is, I'll even put it as a note, because the original function, which one is it again? F of x? F of x has this restriction on its domain. When I put together a composite function made of two other functions, that's a rule that the composite function has to have the same domain and range restrictions, maybe even more so than the original functions did, right? So, in fact, the exact right answer for g of f of x, if you looked at an answer key for a textbook, if this was a textbook question, it would say this, and then it would put that restriction. So you have to stay the restriction. This is why, in some ways, graphing is kind of essential to getting this kind of algebra understood, right? You kind of, it's almost, you don't really even think about this. You just go, oh, there's my answer, right? I plugged one into the other and out spit this piece of algebra. But this is part of the answer. This is only true for all numbers of x that are bigger than -3. Because all numbers smaller than -3 die right here because you can't square root negatives. Okay? So, now when I ask you to do this sort of algebra, I'm actually kind of happy here. You don't really have to do this unless we ask you to. If it's a question like this where it's like, well, what's the domain or what's the range, then that's what we want you to do. Okay, so any questions about that? Do you get how the domain on this one has a restriction? Why? Well, again, because, as you can see in the graph, the original function that we put together with the second function doesn't go any further left than -3, so it still can't go further than that, even when we glue those two functions together. Okay, so any question about that? Interestingly enough, notice that this also has a range restriction too. Compare the red line, the linear one, with the quadratic, and notice the red line doesn't go any lower than the quadratic either. So the same thing's true with the range. How come my range can't go any further down than that? Well, part of it is we still can't square root the negative, but even if that wasn't the problem, the parabola doesn't go any lower than that. So when I put it together with something else, that's the resulting function can't go any lower than the parabola either. Okay, cool. Let's do another example. Notes. B. Let's find f of g of x. So f of g of x is the kind of just the opposite. F of g of x means that we're going to put, again, let me write the functions down again, right? F of x is the square root of x plus 3, and g of x is x squared minus 4, right? Okay, so we're going to plug g of x in to f of x. So we're going to get, the square root, and instead of x, I plug in x squared minus 4. Oh yeah, but don't forget the plus 3. Plus 3. So we're going to get the square root of x squared minus 1. And identify the domain. Well, once again, I might go to a graph, and I'm going to ask you, hey, does this, oops. Oh, that's right, okay. Does this look familiar? Do you remember earlier this year we did a unit on square root functions? What happens when you square root a parabola? All right, let's go to Desmos and see. There's my parabola. Oh, actually, that's not the right parabola. Sorry. Oh yeah, that's it. That's the right parabola. Sorry, I was convinced myself it wasn't. What happens when you square root that thing? Who remembers? What can you do with that? Well, do we remember what happens? What happens to all of the values in here? Can I square root negatives? Nope. So they just plain old don't exist. Do you remember what the invariant points are? Where's the places where, when you square root, you flip it? Well, wait a minute. Flipping it would imply that you just turn it in to a positive. I know what you're thinking. You're thinking, well, doesn't it go up here? Oh, I can't show you. Yeah, doesn't it just, come on, hand. Doesn't it just go up here? And the answer is no. It doesn't exist, period. There's going to be a dead space between here and here on my square root graph because you can't square root negatives. And there is an invariant, there's two invariant points. What's the number that when you square root it, you get itself? Remember, this is a nice review of stuff we did a long time ago. Yeah, remember 1? So at this point here, 1, come on, 1. Oh, well, you get the idea. Oh, you know what, I could just type it in. I can type in open a bracket and go 1. So what happens there? So what's the point when 1? What's the original equation again? So that'd be when x is 1, so that'd be 1 comma negative 3. Oh no, actually, sorry, that's when y is 1. Oh, I'd have to actually solve. I'd actually have to solve it. Never mind. I was gonna get fancy here. Y. Where's equals? Equals 1. There we go. And then there, that point there. What is that point? 1 negative 2.36, and then 1 2.36. So that point there. I could put that. So those 2 points, you can kind of see where I had them before, right there and right there. Those are invariant points. And then what happens to all the other values? Well, when you square root all these positive values, as we go up and down here, they just become their square roots, which just makes them smaller. So do you remember now what this is going to look like when we square root this thing? Okay, now, wait a minute. We're actually not square rooting, now that I think about it, hang on, we're actually not square rooting this thing. We are squaring, you know what, I did have the wrong graph. That's the one we want. We're square rooting this thing. So we're square rooting, so that's my invariant point. That's my other invariant point. And it's this part here that's going to disappear completely. So when I graph that, I'm going to get that. Do you remember those graphs? We did those earlier this year. Right? Remember when you zoom in, remember they bulge inward a little bit in this sort of zone. Oops. In this sort of zone in here. Do you remember that? Why is that? Oh yeah, because when you square root a fraction that's less than 1, you get a bigger answer. I know this was months ago, but that's what you get when you graph it. So think about now the domain. Basically, the domain is, well, first of all, I can't have any negative numbers for my range, and my domain doesn't exist. Right? There's no x values between these two intercepts here. So let's go back to the notes and let's actually figure that out. So basically, this thing can't exist between, hop back to Desmos for a second here just to make sure that that kind of makes sense to us. This thing can't exist between the y-intercepts of x squared minus 1. Or sorry, the x-intercepts of x squared minus 1. So, oops, I hit the wrong button. That's better. So my domain is x has to be, what would that be, greater than or equal to 1, and x has to be less than or equal to negative 1. And you could put that into a curvy bracket if you like. If you prefer interval notation, you of course could write it as x can be from negative infinity to negative 1, and from 1 to infinity. And there we have it. That is kind of the composite function lesson. You guys have a composite function worksheet which I don't think I put up here. Look at that. I don't have it on here. I'll have to add a page and call it, how about I call it the number first? 10.3 comp funct worksheet, and we'll add, and by the way, this is not such a bad thing. You should guys, oops, I apparently can't type very well with my keypad here. I don't know what's going on here. Yeah, sure, proofread that for me, would you? It won't let me, I'll just have to retype it. Work sheet. That's better. Okay, this is not such a bad thing for you to watch. I guess the lesson's over. I'll turn off the video, but you know what, actually maybe I'll leave it on. Some of you, or some of my students in my intro calc class had a really hard time attaching pictures to the OneNote page. You're going to open a OneNote page to do the quiz that I'm going to give you on Friday, and I want you to hand it in on the same page as the quiz. It's much easier for me to find that way. And if you can open your OneNote in your phone app, even if you're working on the OneNotes through Teams on a bigger computer or your laptop or an iPad or whatever, you can still open the OneNote file that you're looking at here using your phone, and when you touch the screen, up should come a keypad, and one of the icons sort of on the left-hand side when you're on your phone app version will be the camera. And the camera then can just take a picture and it'll automatically save it right to this page. It's very nice. Now, if you can't do that, if you're working on, say, a computer like I am right now, and you want to put something on this page, well, you have to save it to your computer. So take a picture with your phone, email it to yourself, and then open it, and then you just attach it as a file. So it's really easy. You just insert a file, and then you put in whatever you want. And oh, I don't have this yet. Okay, so hang on, cancel. Let me go to the blog. And where are you, blog? So 10.3 assignment page. Cool. Ugh, I'm not even logged in here. Let me log in. Yep. Hope everybody caught that. My password is ... And okay, so I'm going to download that. So that should appear in my downloads folder now. So now let me go back to OneNote. I said, let me go back to OneNote. Please let me go back to OneNote. Why is this doing this? There we go. Holy cow, that was hard. Okay, so now on this page, I go back and I click on the page somewhere and I attach a file. And there it is. And I plug it in and I insert it. Don't choose the first two. Insert it as a printout. That way it'll come up as something visual that I could now if this was your quiz or something, I can take my red pen and correct stuff. Dun, dun, dun. And that is so much easier than correcting things through Edsby, where I would sit there for everybody's test and type, you made this mistake on question 2, and you made this mistake on question 4. This way I can just do what I normally do when I mark and circle your mistakes and put little comments. And oh, Edsby's dead to me now, let me tell you. This is the way to do it. Okay, so I think I'll stop the video here and I can go back. Some people had some questions. People who don't have any questions, you can either go back to working on the Chapter 8 homework if you're still working on that. You shouldn't be. Hopefully everybody's done the Chapter 8 stuff by now. And you can get started on this assignment right here, which you should all have. If you don't have it, let me know. I could always send it to you. But I think everybody was here the day that I passed out and handed out all the rest of the course's handouts. So if anybody doesn't have this handout, let me know. Okay? And somebody already wants to know a question on this. Okay, good. I can answer that for you, but I think I'll end the video. Okay, so I'm going to end the video. And oh, and I haven't downloaded attendance yet, too. I'm going to do that, too. So I'm going to download attendance. But first, let's end the video. Okay, video over.